Okay, so hi everybody. I wanted to just let you know, this is a case study, not only in restoration, but I think it's a really nice example of not only a multi-agency, but a nice interdisciplinary case study. You know, a lot of folks were involved in this project. Okay, so the Rio Grande doesn't look like this anymore. This is from the 1930s. I'm not sure exactly what the vantage point is, but I think the river is somewhere around 1/4 to a 1/2 mile wide at this place. And this is what it looks like in a lot of other places on the Rio, unfortunately. Long segments of river that are less than 300 feet wide. And, you know, the flows in these areas are confined. You know, the hydrodynamic models of these areas really highlight that the flows are confined, the velocities get well above 2 to 3 feet per second, even at low to moderate discharges of 1,000 or 1,600 CFS. And at a lot of these sites too, you don't see any overbank flooding until close to 4,000 CFS. So, you know, in some of the previous fish presentations, when people were talking about entrainment and moving eggs and larvae and maybe even fish downstream through dams or into the reservoir, you know, these are great conduits for entrainment. And these are also the areas where we've been focusing habitat restoration. There's very little habitat complexity here. So the Interstate Stream Commission really wanted to focus on developing restoration projects in these really confined and sized channel areas, particularly downstream of the Bernardo Bridge. So we started looking between about Highway 60 at about River Mile 130 all the way down to Socorro. And we ended up honing in on about 7 different restoration project sites. 2 of them were at Sevietta Wildlife Refuge, Unit A and B at River Mile 120. For reference, the Santa Casia Diversion Dams at River Mile 116. And all of the other project sites downstream are really named by River Mile. So we'll be covering these other sites. And today my presentation is going to focus mostly on these 5. The commonality again between all of these sites is that there's very little overbank flooding at discharges less than 4,000 CFS. They all have relative perennial flow, even when other parts of the river are running dry, and these sections are highly channelized. So the goals of the restoration projects really were to try to create and maintain off-channel nursery habitat for the Rio Grande silvery minnow at low to moderate discharges. So we wanted project sites to become inundated beginning around 800 CFS and be fully inundated around 2,000. We wanted to create conditions also that would promote passive recruitment of cottonwood and willow. There's a lot of rampant livestock grazing and Chuck, lots of ORV vehicle use here. Oh, there he comes. Chuck, there's lots of opportunities here for game and fish to step in and take care of off-road vehicles in some of our restoration projects. So we did not revegetate. So again, the goal here was passive recruitment. So with the design objectives, we really wanted to focus on backwater habitats. We weren't interested in flow-through channels for a variety of reasons. We wanted these sites to inundate almost every year, given the short life span of the silvery minnow. We wanted to provide nursery habitat during snowmelt runoff every year, if possible, to some degree. Variable flow depths, depending upon at different discharges, and also design these so that they would drain as the flood flows recede. One of the things that we also did was we developed a detailed monitoring and adaptive management plan that was closely tied to this. We collaborated closely with Reclamation as well to come up with so that similar projects that they were building in this reach would have compatible monitoring objectives, including what we call, I'm sure you're familiar with, SMART objectives that have quantitative success criteria and also quantitative thresholds for triggering adaptive management actions. So all of those were tied together to these goals and objectives. Oops. Let's see if I can go back. Okay. So I'm going to show you quickly these different restoration sites beginning at River Mile 114 and working our way downstream. These sites range from about 1.5 acres to as large as about 8.5 acres. And the shape and size and dimension of them really was driven by the topography and the existing vegetation on the site. We were really concentrating in areas dominated by non-native vegetation, and where the topography was lower, where we'd have fewer cubic yards of material to lower to get these sites inundated. All right, so here's River Mile 100.5 on the left, River Mile 100, and then River Mile 99.5. So all shaped a little bit different number of backwater inlets. And all of these sites were constructed. The construction was completed in February of 2019, and we did as-built topographic surveys, and that's what basically I've been showing here. So as everybody knows, we had a great runoff year. I mean, these project sites were designed, remember, to inundate at low to moderate discharges. You know, in the context of recent runoff, we had a heck of a good runoff, prolonged, high volume, peaking at around 5,000 CFS at Santa Casia Diversion Dam. We wanted these sites to begin inundating at about 800 CFS. We had 5 months above 800 CFS. We had more than 3 months higher than 2,000 CFS and a couple of months greater than 3,000 CFS. So no shortage of inundation of the restoration sites. And then for the monitoring program, we had plans in place here, and I've got little color codes where the orange is, you know, we wanted to measure the spatial extent of inundation. So we did that beginning where the sites were designed to start inundating at around 800 CFS, and then we would go back and measure the extent of inundation at, again, at around 2,000 CFS when we were predicting that the sites would be completely inundated. SWCA set up a monitoring program for fish, both for adult silvery minnow and larval fish, and they set up at 4 of these 5 sites, beginning when flows were just around 1,000 CFS and continued all the way through until the sites stopped being inundated. I should also mention that around 2,000 CFS, we were collaborating with the Saver-Balsky Task Force, and they were helping us collect information on flow depth and velocity and water temperature at all the sites as well. On the tail end of the hydrograph, we were out monitoring to see if there were any isolated pools, and the potential for fish entrapment was something we were interested in. And then at the end of the season, after flows subsided, doing vegetation monitoring, looking at not only natural recruitment of natives, but also of non-native woody and herbaceous noxious weeds. So if you look at photographs here, we have GIS for everything, but the photographs provide good enough illustration. So this site is River Mile 100.5 in March when flows were at about 1,200 CFS, and then again a month later when flows were just over 2,000 CFS. So we're certainly meeting our inundation objectives at low and moderate discharges. Same was true at River Mile 112. The fish, I was really excited. Steve Zipper just provided this data to us the other day, and you can see the blue columns are the floodplain restoration sites, the 4 of the 5 restoration sites, and then the I guess whatever color that is on the other end are natural floodplain sites that are close by. And you can see that the adult fish are similar in number, but also a high proportion of the overall fish that were caught in the restoration sites. You can also see that, you know, there was a lot of gravid females and milt-laden males. And I'm not a fish biologist, but to me that sounds like a backwater, you know, orgy going on here. So for vegetation, what we did for each of the sites is we broke it into 20-foot grids across the entire site. And for every single 20-foot grid that had a plant in it, we recorded. So basically presence, absence. And you can see here that, you know, salt cedar was definitely the most common seedling that came in and to occupy the site. For the native vegetation, cottonwood was by far the most prevalent. The proportion of 20-foot grid cells that were occupied by seedlings. Gooding's willow and coyote willow much less so. Noxious weeds, they're there. They're coming in. Ravenna grass, perennial pepperweed, Canada thistle, Russian knapweed, things that are coming in and they're going to spread quickly if we're not on top of it. We also looked at mapping sediment quantity and spatial distribution. And there's two key points that I want to make here. Okay. We had months of inundation, okay? And from a sediment deposition perspective, maybe a worst case scenario, but all of the sediment was really concentrated in the inlets. So, you know, these slides, the different colors basically represent difference between the as-built condition and post-runoff condition. So the brown means an increase in sediment, the purple means a decrease in sediment, so scour. But all the sediment is really concentrated. The other thing that I wanted to emphasize here is that, you know, even though the sediment was just concentrated here, it is enough to partially, if not completely, prevent these sites from inundating at the same design discharge next year without adaptive management. And if you look at some of the volumes of sediment that we had, you know, this is the volume removed during construction at each of the 5 sites. This is the volume that was deposited in each of those inlets. And from a cost perspective, you know, the difference to build this project, you know, assuming about $5 a cubic yard, and this is reclamation building it too, so they're cheaper than hiring a construction contractor to do the work, but still we're looking at about, you know, $250,000 here. Okay, 48,500 cubic yards. This is how much got deposited. Again, after 5 months of inundation at these project sites, we still only had less than 2,000 cubic yards, 25 times less sediment. To clean these out, it would cost, assuming the same cost, you know, less than $10,000. All right, so the next management steps are to work with reclamation, Savory-Balsky Task Force to control non-native plants, work on removing the sediment plugs to get these project sites fully functioning back to the design discharge next year. And the key year 1 take-home points is that these backwater designs are working. They're functioning as intended. There's certainly ways to improve these things, to improve biological response and reduce sediment. The deposition volumes are really small compared to construction volume. All right, and but it'll stop these projects from functioning over time if we're not on top of the adaptive management. Salt cedar and noxious weeds, they're not going to disappear. Have to get on it, but it's a lot cheaper to get rid of these things when they're seedlings than to go back and wait until they're large again like we had to do at the start of construction. Okay, it's a lot more cost effective to maintain these projects than to constantly build new ones. And then monitoring and adaptive management is critical to keep these things functioning. Debbie, I know you're telling me to stop, but there's a couple of key take homes that I really want to make, and Dave's going to loan me a minute, he told me. Middle Rio Grande is a novel ecosystem, okay? And I think it's really important to emphasize this, okay? Novel ecosystem, if you're not familiar with it, I can send you papers on it, but basically key ecosystem processes have been irreversibly altered, and what we're not doing is restoration. What we are doing is rehabilitation. And I think the sooner as a community we embrace that, the sooner we can come up with realistic plans for how we're going to move forward and ensure that we meet our goals and objectives. It requires long-term stewardship and a real commitment, and that's not only financial, but how do we engage communities to implement the adaptive management and stewardship that's needed to make sure it's cost effective and make sure that they're an integral part of the long-term stewardship of these programs.
Hello. Hey, Todd. So with the extreme hydrology going on, like 18 there was nothing, 19 there was everything. And in these projects, is there a way of reevaluating or redesigning these where instead of the 800 and the 2000, now we're looking, you know, what's it going to be like with 400 CFS and then 5,000? Is there a way you can kind of scrape off and rework them to where I guess they work better at the extremes instead of kind of in that center?
Yeah, you definitely could do that. I think that the 800 was a number that, after looking at the flow records in this particular reach, 800 CFS was something every year we were getting during spring runoff for a minimum of 10 days. So that's how we arrived at that number. We didn't just pick it blindly. But if we needed to build them to inundated 400 CFS while you're out there, you know, I mean, the difference between 800 CFS and 400 CFS might be 6 inches. So, you know, that wouldn't be a problem. Okay, thank you.